Hey everyone, welcome back to my company-wise DSA series. Today's problem is episode 18, Duplicate Subtree, a popular medium-level Google and Amazon interview question. This problem we are given a binary tree and we need to check whether it contains a duplicate subtree of size 2 or more. And a single leaf node is not considered as subtree. We are looking for duplicates with at least 2 nodes. Here you can see the subtree. 2, 4, 5 appears twice. Once on the left and second one is right. So the output will be 1, meaning one duplicate subtree exists. Let's think how we can detect duplicate subtree efficiently. We can represent each subtree as a unique string that includes its root and both subtrees. For example, for node 2 having 4 and 5 left and right, we can form a string and we will use a hash map to count how many times each subtree string appears. If any subtree appears more than once and it's not a single leaf, then we have found a duplicate. This approach takes big O n time and big O n subspace using postorder traversal. We create a helper function solve that returns a string representation of each subtree. It also takes a hash map to track all subtree patterns and a boolean flag to record if we found a duplicate. If our current node is null, we can return this $, to mark the absence of a child. This helps us to keep the subtree string structure unique. We recursively get the serialized string for the left and the right subtree. Now we can form the current subtree unique string by combining the current node's data, left subtree string and the right subtree string. We increment the count for the subtree in the map. If it reaches 2, that means we have seen this subtree before. It's a duplicate. We check that this isn't a single leaf node. It must have at least one child. If so, we mark found true. In our main function, we create a hash map called the recursive helper. And now return 1 if we found any duplicate subtree, otherwise 0. Time complexity big O n. Each node contributes one unique subtree serialization. Space complexity big O n for the hash map storing subtree strings. And that's it. We just solved the duplicate subtree problem efficiently using hashing and postorder traversal. This is a classic binary tree plus hashing interview question often seen in Google and Amazon coding rounds. If you found this explanation helpful, hit the like button, subscribe and comment. See you in the next one, episode 19.